I'd like to begin by thanking ARM for creating this forum and for inviting me out to share Ossium's work today. So our mission is to improve the health, vitality, and longevity of human beings through bioengineering. And fundamentally, the way that we've began that process is by uniting two fields that historically have been very separate. So our organ transplant ecosystem in the United States, and indeed worldwide, is primarily based on deceased donors. About 80% of all organ transplants nationwide are from deceased organ donors. Our bone marrow transplant ecosystem for blood cancer patients is almost entirely reliant on living volunteer donors. The problem with this paradigm is that many of the people who require bone marrow transplants, about 45%, never receive them. And so our organ transplant ecosystem has succeeded at dramatically increasing the number of solid organ transplants that are done per year in the United States over the last 40 years. We've gone from just a couple thousand organ donors a year to about 14,000 donors a year that enable about 50,000 organ transplants every year. And so part of the basic idea behind Ossium is to see some of the enormous growth that we've seen in the availability of organ transplants, to translate that to bone marrow transplants so that more patients can really get access to this life-saving treatment for blood cancer. So the United States is divided into 57 geographic regions, each of which has a nonprofit organization in it called an organ procurement organization. These OPOs have a legal monopoly over the recovery of organs and tissues from deceased donors in their specific geographic area. And Ossium has built partnerships with more than half of those organizations now. So about 180 million US adults now live in an area where if they become an organ donor, their bone marrow goes to Ossium. So there's many things we can do with organ donor bone marrow. What we actually receive from the OPOs are the vertebral bodies. So we developed a process for recovering bone marrow from the vertebral bone, the spinal column of an organ donor. Those of you who are familiar with living volunteer-based bone marrow recoveries will know that usually the iliac crest is used. The VBs actually contain the majority of the hematopoietic cell-rich bone marrow in the adult body, and we're able to recover enough bone marrow from the VBs to do several bone marrow transplants. So that's the first unlock. Rather than one donor, one recipient, we go from a one donor, a multi-recipient paradigm, and on average, we're able to recover enough bone marrow to do 3 to 5 transplants per organ donor. But there's much more that you can do with the vertebral bone from organ donors and simply enable a traditional bone marrow transplant. That's tremendously important, but it turns out that it's also possible for us to use the reservoir of cells in the bone marrow as a source of cells that can be cultured and engineered for cell therapies. And so the vertebral bone is a rich source of mesenchymal stem cells. The bone itself can also be used to make orthopedic products. And more recently, we've launched a viable bone matrix product for patients suffering from orthopedic trauma, foot and ankle injury, and who require a spinal fusion. So all of this is made from the bone of organ donors. Okay. So over the last 70 years, there have been about 1.5 million bone marrow transplants for patients with a range of blood and immune diseases. When we do a bone marrow transplant, we permanently replace the blood and immune system of the recipient for that of the donor. They'll produce cells with the donor's genetics for the rest of their life, and there are about 70 different indications that bone marrow transplants in principle can be used to treat. And there are basically 3 problems with today's sort of volunteer donor-based ecosystem. The first is that there are not enough donors. More than 40% of the people who go looking for a donor never actually receive a transplant. The second problem is that even for those that succeed at receiving a transplant, it takes too long. Typically, patients will have about a 3 to 5 month period between when they begin their search for a bone marrow donor and when they actually receive a transplant. That delay is important because the patient's probability of still being alive at the end of 5 years declines by about 1% for every 3 days they wait for the transplant. And finally, there are too few cells. If we're doing an aspiration from a living donor, there's no opportunity and no time to fully characterize the graft before it's transplanted. You simply aspirate, ship, and infuse. With our method, we're able to not only recover many more cells, but also characterize the graft fully in advance and give the physician the opportunity to choose an optimized dose of cells for the patient. So this is what the transplant ecosystem looks like today. Every year there's just under 20,000 leukemia patients, primarily, who go in search of a donor, some MDS patients as well. who go in search of an allogeneic bone marrow transplant. Of those patients, about 4,000 to 5,000 have a relative who turns out to be a good match for them, and they get a transplant that way. There's another 5,000 or so who receive an unrelated match from the registry, and then there's a few hundred patients who receive a cord blood transplant. We fully have another 9,000 plus patients who do not receive a bone marrow transplant. Many of these patients become so weak during the process of waiting that they're no longer eligible for a transplant, and many of those patients ultimately die. So the basic foundational insight behind Ossium is that by tapping into a population of donors that we know is healthy enough that their organs can be provided for life-saving bone marrow transplants, using that same source of donors to take that orange bar on the far right that covers about almost half of all the people diagnosed with leukemia going to look for a bone marrow transplant and enable those people to receive the treatment. Okay. So this is a schematic of what our process looks like from beginning to end. Everything begins with the organ procurement organizations that we partner with to the recovery of the spinal column. The VBs are then shipped to our facility. We have a 33,000 square foot facility in Indianapolis where we do tissue processing, cell processing, and cryopreservation of our bone marrow and bone marrow-derived products. From there, data on the donors, including their HLA type, is provided to the registry, the National Marrow Donor Program's Be the Match Registry, for matching with patients, and then is shipped from our facility to the transplant centers for infusion. So one way of summarizing the impact of the work that we've done to date is we've taken a process that historically has really been a service. We've waited until after patients have been diagnosed with a hematologic malignancy and then begun the search for a donor for those patients to enable a transplant. Instead of that, we're productizing it. We're doing those steps in advance. And so really, even the HLA identification, that characterization and the HLA confirmation, we do in advance. And so at the time when a transplant is necessary, we simply look for a matched donor in our registry and then ship. The transplant can be done in a matter of days instead of months. Okay, so we've officially announced our partnership with Be the Match just a few weeks ago. And here is a summary of the clinical study that we're doing now, in which our hematopoietic progenitor cell, marrow, is being used for patients with acute leukemia. We're targeting patients between ages 18 and 70. We're using a mismatched unrelated donor protocol for these patients. And so these patients will be people who don't have a perfectly matched donor in the registry already or a relative who's a perfect match. And they'll have anywhere from 1 to 4 mismatches. We have a protocol that enables these patients to receive a transplant with a dramatically reduced risk of graft versus host disease compared to historical precedent by using post-transplant cyclophosphamide. Okay. All right, and there are about 8 bone marrow transplant centers around the United States that are currently either participating in this study or that are on track to participate in our initial study. Ultimately, our goal is to have about 15 to 20 centers nationwide participating in the program before ultimately rolling it out to all 180 bone marrow transplant centers in the United States. Okay. So our core and our initial product is our hematopoietic progenitor cell bone marrow, but it's not the only product that Ossium makes. We also have determined that the vertebral bodies are a rich source of mesenchymal stem cells. In particular, because we have access to the actual interior of the vertebral bone, we're able to enzymatically digest cells off of the walls of that bone, and we can get a few orders of magnitude more primary cells than is possible if you're relying on aspirate from a living donor. And so this enables us to make very large numbers of doses of MSCs from a relatively small, from individual donors at very low passages. So one application of these cells is treatment of graft versus host disease. And so GVHD is it's the principal complication of bone marrow transplants. And you do a hematologic reconstitution. The patient, for the rest of their life, has the blood and immune system of their bone marrow donor. If they're not well matched to the recipient, then the new immune system can essentially attack the host. And so what we find is that if you look at the data, most sources report that about 15% of death after bone marrow transplants is attributable to GVHD, but this is actually somewhat misleading because the other sources of death include infections that result from the immunosuppressants that patients take to mitigate the graft versus host disease, and organ failure, also caused by the GVHD. And so there's about 60% of all the deaths that patients suffer after receiving a bone marrow transplant are related to GVHD or the treatments the patients are taking to mitigate GVHD. It's actually a more likely cause of death than a relapse of the primary disease. And so part of our goal here is to make bone marrow transplants significantly safer so that more transplants can be done. I mentioned earlier that you have about 20,000 patients each year who go looking for a donor in the US, but there's more than 60,000 patients diagnosed with a blood cancer that in principle could be treated with an allogeneic bone marrow transplant. More of these transplants aren't done simply because the procedure right now is very taxing and very dangerous. And so our goal is to both increase the number of procedures that can be done by making it fundamentally safer and increasing the speed and efficiency and quality with which the procedure can be done by making the bone marrow itself far easier to get. Okay. Let's skip this. Okay. So we have a phase 1 clinical study for treatment of GVHD that'll be launching early next year. And again, this program is really designed to complement the bone marrow transplant program. I briefly mentioned earlier that we can also make orthopedic products from the vertebral bodies that we obtain from organ donors. And so this is our newest therapeutic area, and it's one that we're very excited about. So once we receive the spinal columns from the donors, the first thing that we do in our facility is tissue processing. We clean and debride the bone, and we separate the VBs, and then the VBs are sort of ground and the bone marrow is eluted out. And the vertebral bone then goes down a separate pathway for making our viable bone matrix product. There's many things about using the same donors that we use for bone marrow and bone-based products that open up an enormous amount of opportunity. In particular, there's a hierarchy in organ recovery. We recover the solid organs that are life-saving first after the time of death, and tissues like bone are typically recovered later. The bone marrow is an organ. The bone marrow is life-saving. A bone marrow transplant saves a life in the same way that a heart or a kidney transplant saves a life. And so we're able to recover the bone from the donors much earlier after death than anyone else who's using bone from organ donors to make bone putty products. And so the goal there is to really have a product with more living cells that's more viable, that enables healing and recovery after a traumatic orthopedic injury more rapidly. So the product is called Ossograft. It's launching in just over a month. And because the donor population that we're using for this product is the same as the bone marrow product, the donors are younger. We choose young, healthy donors for bone marrow processing because the data shows that the younger the donor for the bone marrow transplant is, the better the patient's outcomes are. And so what we're really trying to do is to bring the same level of rigor that we have approached our oncology products with into the orthopedics market, and we're excited about the impact of that. Let's see here. Okay. So the company's raised about $120 million over the last 6 years from a mixture of life science and tech investors. And this is our leadership team. Okay. So our pipeline has 3 major categories of products in it. There's the bone marrow products used for treating hematologic malignancies, the viable bone graft product, and then there's a whole suite of interferon gamma primed synchronized mesenchymal cell products. And for those products, we receive report from CERM. Okay. One thing that we do want to emphasize is the critical impact for patients of simply taking the bone marrow transplant process, which for now is a bespoke sort of post-hoc service, and turning that into a productized model. In particular, the impact of speed. And so if you look at this graph, you can see the survival curves for patients who receive their bone marrow transplant with early, intermediate, and advanced stage disease, and this is focused on AML patients. And what we see is dramatically better outcomes for patients who are able to receive their transplants more quickly. We see similar outcomes for MDS, where there's a very significant impact of the amount of time that the patient has to wait between when they go in search of a donor and when they receive a transplant. This time period can't be helped using traditional methods. Our goal is to elevate all of the patients to the outcomes that are possible if they receive their transplants in just a few weeks after beginning to look for a donor. We're excited about sharing data on the clinical outcomes of that at an upcoming meeting. Thank you.